Today I am going to start a new chapter which is called a transformation of equation. So what is transformation? Transformation of equation. So we will discuss every transformation by a question. Example number 1. So question number first. Form an equation. Form an equation whose roots are whose roots are the roots whose roots are root of the equation with the sign change. Whose roots are roots of the equation x raised to power 4 minus 3x raised to power 3 plus 7x minus 1 equal to 0. So with their sign changed. So with their sign changed. Solution. So how we will solve this kind of equation? Now first step is the given equation. Is, so this is a x raised to power 4 minus 3x cube. Now the third term is missing, so I can write it as 0x raised to power 2 plus 7x minus 1, which is equal to 0. So this equation is called complete. Now the transformed equation is, so just we want a new equation with the root whose sign is changed. It means if the root of first equation is a, b, c, d, then the next transformed equation have a root minus a, minus b, minus c and minus 3. So here we will apply the transformation y is equal to minus x. Here ja x is equal to minus y. So here we will apply the transformation x equal to minus y. So when we substitute this transformation in equation number 1, so it implies minus y raised to power 4 minus 3 raised to power plus 0 minus y raised to power 2 plus 7 minus y minus 1, which is equal to 0. So this equation will become y raised to power 4 plus 3y cube and plus 0y square minus 7y minus 1 equal to 0. Now since y is variable, so we can write it in term of x. So x raised to power 4 plus 3x raised to power 3 plus 0x square minus 7x minus 1, which is equal to 0. So this is a new equation whose roots are, this is a new equation whose roots are negative of the root of the given equation. So in this way we can find the new equation, the transform equation whose roots are negative of the root of the given equation. Now this is my first method to find the transform equation whose roots are negative to the root of the given equation. Now the next is very important type. So that is a just first write the statement of the question. Now transform the equation. Transform the equation 36 x raised to power 3 minus 54 x raised to power 2 plus 45 x minus 8, which is equal to 0, into 1 into 1 in that equation, which has integral coefficient, which has integral coefficients coefficients and leading coefficient is unity, and leading coefficient is unity. So this is very important type. So leading coefficient is unity. So we will transform this equation whose coefficient are integer, number 1, and leading coefficient is unity. So these are, it contains 2 steps. So step number 1, the coefficient are integer, and step number 2, so leading coefficient is integer, a leading coefficient is unity. Now what is the given equation? The given equation is 36x cube minus 54 x square plus 45 x minus 8 equal to 0. So this is a given equation, step number 1. So this is equation number 1. Step number 2, to make the leading coefficient 1, so we will divide by the entire equation. So I get x cube minus 54 by 36 x square plus 45 over 36 x minus 8 by 36 equal to 0. So divide by 36 on the entire equation. Now simplify it. So this will become x cube minus, so this term is 3 by 2 x square, and next term is plus 5 by 4x, 5 by 4x, and next term is minus 2 by 9 equal to 0. Now the leading coefficient is 1. Now my purpose is to make these coefficient as integer. Now in this way we see that these term contained a prime number 2 and 3. So this is a multiple of 2, this is a multiple of 2, and this is a multiple of 3. So this is a, this terms contains a prime number 2 and 3. So this equation can be written as x cube minus 3. So this is 2 raised to power 1 into 3 raised to power 0 because it contains no term of 3. So x square plus 5 by 2 raised to power 2 into 3 raised to power 0. Next is minus 2 by 2 raised to power 0 into 3 raised to power 2, and this term is equal to 0. So this is my next step. Now to find the multiplier, if I write to find the multiplier, so this multiplier is, let m is multiplier. Suppose m is multiplier. Suppose how we will find the multiplier. So this is very important step. So multiplier m may be 2 raised to power r into 3 raised to power s. Now my aim is to find the r and s. So just check that the power of 2. To find the r, we check the power of 2. So power of 2 in quotients are, what is here, 1, 2 and 0. 1, 2 and 0. This is the power of 2. Now divide them 1, 2 and 3 respectively. Divide them 1, 2 and 3 respectively. So this becomes, it implies, so this is 1 by 1, 1, comma 1, and this is 0. So what is the r? So r is least positive number. What is r? R is least positive integer not less than any of these quotient. Least positive quotient not less than any of these quotient. Not less than any of these quotient. Now check that. So here the value of r will be 1 because so least positive integer. So the least positive integer are 0 and 1. But 0 is less than 0 and 1. So my aim is to find a least positive quotient not less than any of the quotient, right? So the quotient are, this is 1, 2 and that is a power. So not less than quotient. So what is the quotient? This is a, so this means r is equal to 1. So 1, 1 and 0. So least positive integer but not less than the quotient, that is equal to 1. Now similarly, in case of raised to power 3, now what is the power of, again understand the same, power of 3r, which is equal to 0, 0 and 2. 0, 0 and 2, right? Now divide it by 1, 2 and 3. So quotient becomes 0 by 1, 0 by 2 and 2 by 3. So what is this? This is a 0, 0 and 2 by 3. Now what is my aim? To find the least positive integer not less than this. So this is 0, this is 0, this is 0.7. So not less than this. It means the least positive integer not less than these three numbers, that is a 1. So value of S is again 1. So what is S? So S is a least positive integer not less than any quotient, quotient, right? So it may be again 1. So in the previous, R is, which is equal to 110. So this is the least positive quotient not less than any of these quotient. So that is a 1. In this case, R is 1. And in the second case, S is equal to 1. So multiplier will become M, which is equal to 2 raised to power 1 into 3 raised to power 1. So this value is equal to 6. So we get the multiplier. So multiply is equal to 6. So this is a multiplier. Now multiply the root of equation 1 by 6. Now my step is, next step, multiply the roots of equation 1 by 6. So what it means? It means the transformation is y is equal to, x is equal to 6y. X is equal to 6y. So this is a transformation. In the simplest way, we apply this result to the equation number 1. So what is the equation number 1? So this is a x raised to power 3, these values. Now minus 3 by 2 x raised to power 2, this is second equation, plus 5 by 4 x raised to power x, 5 by 4 x, and next is minus, which is 2 by 9, which is equal to 0. This is. Now first term is multiplied by 6 raised to power 0. Remember, if we transform the equation whose roots are multiple of 6, a multiple of m. So first term is multiplied by m raised to power 0, means 6 raised to power 0. Second is 6 raised to power 1. And third is 6 raised to power 2. And last is 6 raised to power 3. So simplify this calculation. So what we get? We get this term, which is equal to x raised to power 3, and this term will become 9 x raised to power 2 and plus 45 x minus 48 equal to 0. So this equation is whose coefficient are integers and leading coefficient is 1. So which is a required equation, So in this way we can transform the equation of this term, so this given equations, right? So this is very important type. So I will discuss the question of same type. The statement is, this is very again important question that was asked in Guru Nanak Dev University 2007. Now transform, the statement is transform the equation 5x cube minus 3 by 2x square minus 3 by 4x plus 1, which is equal to 0, into another equation whose leading coefficient is unity, and other coefficients are integer. Coefficients are integers. So same type, integers. So discuss another question. Now solve this equation. So solution. First write the equation in complete form. Complete form means no term is missing. Now this can be written as x cube minus 3 by 10 x square minus 3 by 20x plus 1 by 5. 3 by 20x by 1 by 5 equal to 0. Now this can be written as x cube minus 3 by 2 raised to power 1 into 5 raised to power 1 x square minus 3 by 2 raised to power 2 into 5 raised to power 1 into x plus 1 by 2 raised to power 0 into 5 raised to power 1, which is equal to 0. So this is equation number 1, suppose. Now to find the multiplier. So let m is multiplier. So here m is multiplier. So this can be written as 2 raised to power r into 5 raised to power s. So here there are two prime factor, one is 2 and 5. So just check that 2, 5, 2, 5 and 2, 5. So first find the value of r. Now power of 2 is, first power of 2 is, which is equal to 1, 2 and 0. Now divide by 1, 2 and 3 respectively. So quotient is 1 by 1, 2 by 2, 0 by 3. So it means this value is 1, 1 and 0 here. So what is R? So we will find R. So what is R? R is least positive integer, least positive integer not less than quotient, not less than quotient. So these are the quotient 1, 1, 0. So it means R is equal to 1. So R is equal to 1. This values. Now in this case, in the case of 5, so power of 5 is 1, 1 and third is 1. All the power is 1. Now divide by 1, 2 and 3 respectively. So what is the quotient? So quotients are 1 by 1, 1 by 2, 1 by 3. So it means 1, 1 by 2 and 1 by 3. So what is S? S is least positive integer not less than quotient, not less than quotient. So this is again equal to 1. So S is equal to 1. So we get the multiplier. So 1 is R1. So S1. So multiplier is 2 raised to power 1 into 5 raised to power 1. So multiplier is 10. If multiplier is 10, now we will find the equation whose root are multiple of 10. So multiplying the roots of equation 1 by 10. So multiply by root of equation 1 by 10. So this will written as 10 raised to power 0, x raised to power 3. So first is, next is 10 raised to power 1 into 3 by 10 x raised to power 2 minus 10 raised to power 2 into 3 by 20 x, and next is 10 raised to power 3 into 1 by 5, and this value is equal to 0. Now simplify this equation. So we get the transformed equation x cube minus 3x square, and this next term is minus 15x, and next term is 200, which is equal to 0. So this is a equation whose leading coefficient is 1, which is required equation whose leading coefficient is 1 and the remaining coefficients are integer. So in this way we can transform the equation to the next. Now next type is find the equation whose roots are reciprocal of the root of the equation. So next type, find the equation, find the equation whose roots are reciprocal whose roots are reciprocal, this is reciprocal of the roots of the equation, of the roots of the equation. So what is equation? So equation is x raised to power 4 minus 3x raised to power 3 plus 2x square plus 2x square plus 7x plus 7x plus 1, which is equal to 0. So this is equation number 1. So this is my equation. Now solution. So first part, the given equation, which is x raised to power 4 minus 3x raised to power 3 plus 2x raised to power 2 plus 7x plus 1 equal to 0. So this is the equation number 1. So first step, that is a given equation. Now here we will apply the transformation, that is y is equal to 1 by x, because this we required an equation whose roots are reciprocal to the previous equation. Then it implies x can be written as 1 by y. Now substitute the value of x in equation number 1. So this will become 1 by y raised to power 4 minus 3, 1 by y raised to power 3 plus 2, 1 by y raised to power 2 plus 7, 1 by y plus 1, which is equal to 0. So this is our result. Now simplify. So multiply by y by 4 on both sides on the equation. So what we get? We get y raised to power 4 from this plus 7 y raised to power 3 plus 2y square minus 3y plus 1 equal to 0. So which is a required equation whose roots are reciprocal to the equation number 1, which is required equation. So which is a required equation. So that is my result. Now in this way we can find the equation whose roots are reciprocal to the root of the given equation. Now we will apply this transformation to find our next question. So what is the statement of our next question? The roots are in HP, so we'll convert the roots in term of AP. So statement of the question is solve the equation, solve the equation. What is that equation? 6 x raised to power 3 minus 11 x raised to power 2 minus 3x plus 2, which is equal to 0. So given, so this is a given equation. given that roots are in HP, harmonic progressions. So we know that if roots are in HP, then the reciprocal of these roots are in AP. So we will convert this equation, transform this equation whose roots are reciprocal to the previous one. Now, solution to solve this equation. So first step, given equation is, the given equation is 6x cube minus 11x square minus 3x plus 2 equal to 0. So which is equal to 1. Now roots are in HP. So we convert this equation, transform this equation into a new equation whose roots are reciprocal to the roots of equation number 1. So that will become 2y raised to power 3 minus 3y square minus 11y plus 6 equal to 0, and this is the equation number 2. So that is in y. Now it is a cubic equation, so it has 3 roots and 3 roots. So since root of equation number 1 is HP, then it implies roots of equation number 2 are in AP, arithmetic progression. So its root are in AP. So let its root is A minus D, A, and A plus D be roots of equation number 2. So remember that the root of equation number 2 is A minus D, A and this. So what is the sum of root? So this is a 3A. So what is sum of roots from the given equation, the Whiteley lemma? So this will be minus 3 over 2. So this is a 3 by 2. If it is a 3 by 2, so what is the value of A? So value of A is equal to 1 by 2. So which is a root of equation number 2. So we get a 1 root of equation number 2. So the remaining 2 root can be find out with the help of 3 by, this is a 1 by 2, 1 root. So what is its coefficient? 2 minus 3 minus 11 and 6. So this values. Now from this we will find the other remaining 2 root with the help of synthetic division. So this will be 1. So 2 minus 2, and this is minus 1. So this is minus 12. So this is a minus 6. So remainder is 0. So remaining quadratic equation is which is equal to 2y square minus 2y minus 12. So to find the root of this quadratic equation, so it means 2y square minus 2y minus 12 equal to 0. So it implies y square minus y minus 6 equal to 0, this values. So what is the root? Y is equal to 1 plus minus b square plus 24 square root over 2. So this is 1 plus minus 5 by 2. So this is a 3 and minus 2. So we get remaining two root minus 2 and 3. So what are the root of equation number 2? So root of equation number 2 is 1 by 2 minus 2 and 3. So these are the root of equation number 3, equation number 2. So what will be the root of equation number 1? They are reciprocal. So roots of equation number 1 are, so taking reciprocal, so this is minus 1 by 2, 2 and this is 1 by 3. Now taking the reciprocal, so what we get? We get the roots which is 1 by 3 minus 1 by 2 and 2. So this is a root of our equation. So in this way we can find the root of harmonic progressions. So we will convert that equation into the new equation whose roots are reciprocal. So it will be converted as HP into AP. So that we already done that kind of question. So we will solve by that method. Now again, next question is find lambda. So this is some constant and solve the equation and solve the equation 40x raised to power 4 plus lambda x raised to power 3 minus 21x raised to power 2 minus 2x plus 1 equal to 0 and given roots are in HP, harmonic progressions. So that is my question. To solve this equation, so first the given equation is 40x raised to power 4 lambda x raised to power 3 21x raised to power 2 minus 2x plus 1 which is equal to 0. So this is equation number 1. Now put x equal to 1 by y. So what is new transform equation? Transform equation, a new transform equation y raised to power 4 minus 2y raised to power 3 minus 21 y raised to power 2 plus lambda y plus 40 equal to 0. So this is equation number 2. Now root of this equation is, so roots of equation 2 is the are in AP. Roots of this equation is in AP. It has biquadrant equation. So root of equation number 2 are in AP. So what is the sum of roots? So sum of roots, sum of roots which is equal to -1 into -2 over 1. So this is equal to 2. Now in case of, it is a sum of all 4 roots. All 4 roots. Now in case of sum of all 4 roots which is equal to 2 and sum of each pair of 2 roots, pair of 2 roots which is equal to 1, 2 by 2 which is equal to 1, because in case of AP the sum of 2 root is equal to sum of other 2 roots. For example, if alpha, beta, gamma, delta are roots, so alpha plus beta and gamma plus delta, they are equal, and this value is equal to 1. So remember that. Now suppose, assume product of these two roots is equal to small p, and product of these two roots, this is equal to small q. Then the quadratic equation whose roots are, the quadratic equation whose roots are alpha beta, that is y square minus y plus b, and here it is y square minus y plus q, this value. Now simplify, this value is p, so this is y raised to power 4, coefficient of this, and cubic equation, this is y raised to power 4 minus y cube, so this is minus y cube minus 2y cube. Now square py square, this is plus p plus q, so this is plus 1 into y square, this values, this into this, and third is y, so this is minus p plus q into y, and last is constant term product, so this is equal to pq. Now comparing the equation, we get p plus q plus 1, and second is p plus q which is equal to, and third is pq. Now comparing this equation, so what we get, now comparing the equation number 2, minus 21 minus lambda and plus 40. So what we get minus 21, so this is plus lambda, so minus lambda, and this is plus 40. So from this p plus q which is equal to minus 22, so it means lambda is equal to 22, so we get the value of lambda. So this is my first result, and second is pq which is equal to 40. Now to find the value of p and q, so we construct a quadratic equation whose roots are p and q. So that equation is t square minus p plus q into T plus product PQ, which is equal to 0. So it implies T square plus 22T plus 40 equal to 0. It implies T plus 2 into T plus 20 equal to 0. So it implies T has two values. One is minus 2 and second is minus 20. Now it means one root is P and second is Q. So it implies the value of P is minus 2 and value of Q is minus 20. So we get two quadratic equation. One is x square and this is from P, the value of P is, we find that. So x square minus y, y square minus y. So here it is y square minus y plus P. So minus 2 equal to 0. Second is y square minus y plus q minus 20 is equal to 0. So we get 2 root of y, this equation. So what is y? Y is equal to 1 plus minus b square 1 plus 8 by 2. So this is equal to 1 plus minus 3 by 2. So this is equal to 2 and minus 1. Now in this case y is equal to 1 plus minus this square 1 plus 80. So this is 81 by 2. So 1 plus minus 9 by 2. So this is equal to 5 and minus 8. So this is minus 4. So roots are minus 1, 2, minus 4 and 5. This is roots of equation number 2. But my requirement is root of equation number 1. So that is reciprocal of this. So what is the reciprocal? Minus 1, 1 by 2, minus 1 by 4 and 1 by 5. So this is a roots of the roots of the given equation 1. So which prove our result, and what is the value of lambda that we already find in this equation. So these are the root of our equation. So lambda is 22 and this is a